Welcome to this UASMaster video tutorial. In this video we want to show you a combination of the UASMaster software and also another product from our info software is OrthoVista, where you can do radiometric correction for your orthophotos and Seamline editing. And we want to show you here how you can take the results from UASMaster into OrthoVista. First, you need to go to your options and into your preferences, and you need to define that your working directory is within the project directory and that you back up previous processing results. You don't need to do it really, but it will make it much easier for you to work, because then your orthophoto processing steps, they will be then within your project folder, and it makes the whole thing just easier. And in case you run something else, it will not be destroyed or overwritten, as the temporary folder, typically when you have the standard setting, will be always overwritten with the next process step or next project that you do. And so you will have your orthophotos stored, and they will stay in this backup result file, temp file, and we will see this in this process. Okay, so you have to finish your georeferencing part, so you have correctly orientated images, and so we can go into the surface and orthophoto generation. And then of course we need to have a surface generated, and in this video tutorial here we will just show the process. So I will here run a feature-based matching, and this feature-based matching here will be just run here with a medium extraction level, so it's running very quickly through it. And then normally after the process is done, we should then of course eliminate errors like when there's a bump in buildings or in vegetation. Then you can run the whole editing steps in UASEdit, but we will here just jump over this part, and then we will run in, after the terrain model here is extracted, the orthophoto production, and these files will be stored in our project folder too. And we will then take these results and move them to OrthoVista. So after this DTM is now processed, we will then continue now with the orthophoto production. So here we go, our terrain model, and we go into orthophoto generation, and we will run here, I will here run it on 3 centimeters, and I will run a classic orthophoto production. What I will start it, because then we can already talk about it. I will use all the data. You could here already move points to off ground and ground, and therefore here already here use a better terrain model. What happens now here is that we run info technology in the background. So there is an orthophoto generation process happening. So for each single photo, aerial image or drone image, we will create an orthophoto. And this is then based here on parameters that we try always to look as best as possible in a nadir way for each drone image. So if you have, for example, one image that looks or you have an image content where you have a center part, then probably this will be also auto-rectified. But then the further you go to the border of your image, the more you have an angle, and that can occlude behind buildings, it can occlude behind trees, so you cannot see behind the tree, you cannot see behind the building. And therefore these areas of the images, they are hopefully also covered from other images that look nadir. Yeah? So if you have a building then you can have an image that is perfectly on top of the building. This is the image we will prefer. And then you have images that are a little bit more to the left, to the top, to the bottom of the building. And then we will not prefer this image. This is then done by calculating our footprints of each image. We use the orientation information, so the XYZ position, of course, but also the omega phi kappa values. We have a terrain model, so we can calculate where this footprint is located on the ground, and therefore we can then also see the angle, how we look at this position, and then we can say, okay, preferably we will use image A or image B or image C. And after this is then defined, we will then still keep areas overlapping. So that means orthophoto produced from image A and orthophoto from the neighbor image B will still have same content. Yeah? So this is the orthophoto overlap. And this overlap is something that we will now use in OrthoVista, because then we can decide with a Seamline definition which part of this overlap area we want to consider. So do we want to use the image content from image A, which shows perhaps the road without a car because the car already passed by, it was moving. And in image B, there would be still perhaps a car visible in this area. So then we can move the Seamline around this car, and then this car disappears because we used image A where the car is not existing at this position. And also other parts, when you have shadows or you have here perhaps some blurred images, then we can here also say, okay, we will not use much content of this blurred image, only if we need to use some specific imagery, then we can here make our selection. And these Seamlines, they need to be done manually. So that's why we in our UASMaster process are creating these Seamlines full automatic. And I think it's a very good algorithm that here offers us very often a very nice solution. Even sometimes we will see now the Seamline seems to go through a building or through some trees, but because the projection of the images in this content will not create here a wrong display or a wrong geometric display of the image, then this will very often be a nice solution. But we have now the option to do this, and here we go. So we have now here also the mosaic was generated, and we will now take a look at the output folder of our project to see how this is stored. So here we go. We have now here our project folder, and for each process step there is a subfolder generated. Each of these temporary subfolders contains here one of our processing steps. So here I did run a post process that I'm assured that my images are well orientated. Then the next step is our terrain extraction. So here we have the feature-based matching run that is stored all the temporary files. And now here in this temp folder, we have now our orthophotos, which are stored here in the subfolder 23-rectify. And here we have for each drone image, we have an orthophoto, and we call them just putting here the OR in front of the name. And this here is now then our orthophoto from our drone image DSC 03748, and this is the next one here of 3749. The permit file is here stored as a separate folder file. Then we have here a region file that is describing for the orthophoto what is valid content and areas. Well, let's take here a look perhaps. We see here this black area, and this is non-valid content, and the region file is defining here this borderline. And so we can use then this region file later on in OrthoVista, for example, in a very easy way. So we don't need to evaluate these black pixels, and therefore the region file makes this easier. And the RDX file is our radiometrics file. So in this full automatic run in UASMaster, we already did a radiometric correction between the orthophotos to homogenize them. We are using the intensity values. We also use the color informations, and just to make the different orthophotos to each other more homogeneous, so that we don't have color issues or intensity issues or brightness issues. And exactly these orthophotos we will now use in OrthoVista and load them into OrthoVista, and then we can now ourselves create our mosaic run, but now we can here use also Seamline editing and Seamline correction just to make this whole process easier. We can also do a tiling, so we can here break down this whole project into multiple tiles, making it easier to handle, also to distribute later on the products to our clients. So if you have thousands of aerial images or drone images, then you don't have one huge mosaic file, but you have multiple mosaic files which are seamless to each other. And this is the next step. So let's here close UASMaster, and then we will take a look to OrthoVista. I will in OrthoVista only show here the basic concept of the process, and if you are more interested into it, this is definitely a product worth to try out. And also we offer self-paced trainings for it on the Trimble LMS page for it, so you can take a look and then evaluate if this makes for you sense when you go into larger projects. A quick note how you can get the software. You can get it by going to our download page, and you can find this at geospatial.trimble.com/info-download. And here you can then fill out the download registration, and also here then apply for a demo version of OrthoVista. And after you have then asked for the demo version, or if you already bought it or you have your own OrthoVista, then this is part of the applications master. So it's then when you install it, then you can see here on the standalones there's OrthoVista, and so we can start OrthoVista, and in OrthoVista we can then load in our orthophotos, and this is done here on this images tab. And here on this images tab we can here load either single images, or I will load here a complete folder. So I said add a whole directory, and then I will navigate here to our dataset. So here we go, and here in the temp folder, it's the rectify folder, and I will say select this folder, and then we can now see here our orthophotos. They have GeoTIFF reference, and then they have here these 3 centimeter ground sample distance as a pixel size, and of course they are all north orientated, just to making the whole work process easier. Also during the orthophoto process in UASMaster, we take care that each pixel from the different orthophotos is perfectly overlapping to the next aerial image, so there's no shift between these orthophotos. They have all the same reference point to each other. And when we take a look here, then we can see here these orthophotos, and they are here now covering our area of our project. Next, what we need is our mosaic output definition. And again, going back to our project dialog where we imported the images, we can have here a tile definition. We can here import also a shapefile. So if you already have a clear mosaic definition, or you create these shapefiles in your software, that you have here also some specific naming for each of the tiles, then this is possible. So then you could here also load a tile definition based on the shapefile. In my case here, I will just show here how to do it yourself. So creating here a tile definition file, And what we will do here is I will here create into our project here, I call it here the demo TSP file. And then let's save it. And then we need to define our reference point. And you also can click here into the OrthoVista mainframe. So I will click here. You see here on the bottom right also the coordinates, but we will then fix it afterwards. So I just click somewhere. And then when I click in here and I go back to this window, this coordinate is grabbed. I will just make it here simple for me. So I will here perhaps try just to make this a whole number. And also here I will make it a whole number. And then we can define our tile size, how big each tile is. So perhaps you have a specific definition of mosaics that you need to deliver. I will here make it just easy for our purpose. It's a very small area, so I will just make it 50 by 50. And then here apply. And when we go here, then we see here this is the tile size. It's already directly shown. And then we can here, let me go back to this definition. I will here not make it to the south. I will here make it to the north. And then I say apply. And then we can now see here these tiles, how they are accumulated. And then we can here say, okay, I need 5 to the north. And then I assume something like 5 to the east. And there we go. And then we would then here create our tile definition. This is the basic idea. Of course, for this small project, it doesn't make sense perhaps to really tile it. But imagining you have here thousands of images, then you can here define here your tile definition with these parts. If you leave the tile skip empty, then these tile definitions, they are seamless. It means they directly continue with the next pixel. You also see that my tile that I will generate is not 50 by 50. It will be generated with 50.01, mainly because I have a 3 centimeter ground sample distance. So perhaps 60 should have been a good solution, because 3 centimeters fits a multiple times perfectly into it. And then when we make it now with 60, then we get also 60 by 60. Yeah, so of course your pixel size and your tile size definition, they are related to each other, so you have to be careful here. Then I will, if I don't give a name pattern, they will be here just incremented from 0, 1 to 1, 1 and so on. But I will here also give them just a simple naming. And I will use here a coordinate from the x-axis, the upper left. Then I will here add between here a text field, which is an underscore. And then I will use the, let me edit, I will here use the lower left. And then I will use here finally also the y-axis and also here the lower left. And then lower left X, lower left Y will then be the naming of my mosaics in this case here. That's it. Then I can say here apply. We can also then display here with this button these names here. So we see this is my tile naming. And then we can here close the tile definition and say OK. And when we return here to the project dialog, then we can see here these tiles. In OrthoVista, the tile definition is not the tile production. So that means this is only our definition, and now we tell OrthoVista which ones do we want to process. So in this case here, selecting all of them, then we can hit here the button which calls mark selected tiles at output. And then they are highlighted. We see this here in the background. They are then green. And this is now our production of mosaics that we will do. And it will also then, of course, create now between these orthophotos the Seamline. And that's it. So let's just quickly run the final part. So we say here process, or sorry, one important thing is, in this case, the preferences. You need to be aware to what colors you check for background. You remember my orthophotos have this black background color, but we don't see it here because we are only using as valid values not 0 to 255, but 1 to 255. So that means if I have a pixel with the value 0, which is black in this case on a histogram, then this black pixel is not used. This is also something where we take care in UASMaster in this process that these background images have a pure 0 value as a background image, and so we can say ignore them, just start to use values from 1 to 255. In our case, this is already correct. If not, you need to address this in OrthoVista, and then we can go to the processing, and we will define here an output directory, and I will here just make a new folder and call it here OrthoVista. And in OrthoVista, we will then output here these parameters. Again, as this video is a little bit also a teaser, I will not go now into all these different functions. There we can offer here training, either again, as mentioned, a self-paced training or also an online training. I will now just show how to set up in the basic parts for large projects. That means I will here not save the mosaic, I will just save the adjusted images. I will save here the seam lines. I will run here feature detection part, and I will stick with the remaining parts as they are, also with the Word file and all this part. So let's close and process. And then after the process is done, we will then show you how to use OrthoVista SeamEditor, where we can now manually make the corrections, what part of the orthophotos we use for the mosaic generation. And then also after we did these checks and editings, how to apply them in the OrthoVista process. Also splitting up here into these two main workflows. So here the Seamline generation without the mosaic generation is also from the resources of your computer better, so you can run larger projects with the same computer, and therefore also from the processing time. Of course, this will also then split this into two main production line parts, and therefore also it makes it easier to handle for large projects. So I pause here, and then after the Seamline generation and the orthophoto, not mosaic, the orthophoto generation has been done with the global tilting adjustments here, we will take then the next look into OrthoVista SeamEditor. Okay, here we go. Didn't take too much longer, so it's finished. Let's take a look at the output folder. So here OrthoVista, and as in UASMaster, we have here again orthophotos, but this time these orthophotos have already a radiometric correction applied to it. So we have here already run the automatic intensity correction, color balancing correction, and brightness correction on these photos. And these orthophotos, they should now already look nice in the SeamEditor. Also, we have here an auto seam, which we then could share to somebody to review if this is done correctly or not. Okay, important also, in this output folder, there is here already a IPD file, which is an OrthoVista project file. And this is exactly the one that we will now use in the SeamEditor. I close OrthoVista as the project file was automatically created, so I don't need to save it explicitly. Of course, you can save it and give your own name and also perhaps a specific location on your hard disk. Then we go into the SeamEditor, which is part of OrthoVista. So they are together one product. And here we will open now this project file. So here we go, IPD file, open it. And the nice thing about it is it already has all necessary informations and the metadata part. I will not go into this so much now. It's important, so you should really then here not change too much if you just stick with the default settings. Let's go to the project dialog, which already was open. I shouldn't have closed it. Important in OrthoVista SeamEditor, at the beginning all photos are deactivated. Imagining you have thousands of images, then we would recommend to run something in 500 image blocks to run this seam editing. With drone images, perhaps this can be larger, but with the photogrammetric cameras, we have very large sensors, 200 megapixel and more. So with drones, it's perhaps you can run here 1,000 or 2,000 drone images. This is something we have to you have to check out also with your hardware configuration. So in my case, I can here easily select all of them. So these 41, it's no problem. Important for us here is the button here called Set the Selected Images to Active. We will see after I press the button, these values from unknown will change. And let's take here a look. So boundary exists, Seamline exists, and this is exactly what we want. This Seamline is in our case here this green line. Well, we have to be clear. This is now, I can't go too deep into this. It's not a line in reality. This is a buffer area between these two overlapping orthophotos, but it's represented here by this green Seamline. And now we can here start to edit the Seamline and, for example, avoiding here misplacements, or if two orthophotos are not correctly here smoothly transitioning between each other, then we can do exactly now here this editing. Everything will be stored into the meta folder, into specific meta files. Don't go into this here again too much. Saving the project is the important thing. So let's here hit these three major steps that we need to do. First of all, of course, reviewing if the Seamline created somewhere an issue. By default, OrthoVista, SeamEditor, and OrthoVista have here this drag zoom as a standard one. So what you need is just drag somewhere a box. I will here, let's say, go from left to right. So let's open here along this Seamline here. And then we can see here how the Seamline, where it is placed, and if this causes here now issues, because this is what you see is what you get here. So in this case here, let's here move along, and then we would then see if there would be some misplacements. Yeah. So, and therefore you can then check these parts. You see the line tries to avoid as much as possible vegetation or some objects, and then you can just go along and then here search where the Seamline created here a misplacement, or perhaps the orthophoto is looking not so as we want. In this case, you see also here, typically the automatic one tries here to go along roads or areas that help us where we don't get too much of wrong auto rectification between them afterwards in the Mosaic process. And so we can here go and check these parts. So I will here just go from left to right and hopefully find here a small thing where I can show at least how to do it. So I hope here at the road, I remember there are some tree branches coming in here, and then we can here make a check, and then we can here fix it. So let's say for whatever reason, in this case here, I want this, let's go here. Let's say this line here was not nicely going around these tree branches, and I need to expand this Seamline to go further here on the lower part. And this is now where we can directly also edit in inside of the SeamEditor. And this is done here by these editing tools. So I can here say I want to create a new Seamline. So I say yes. And what now you need to do is digitize polygon. And wherever you place your first point, then this line will be extended from this part. So that means if I want to extend this image here to go further around here, then I just start on the upper part of this line. I perhaps show it, then we can see it here. So I start here, then I go here along, and then I return here back to this part here. Then I just, because if I leave it this way, it cuts this green line here. So I make here another part. And then we can here hit either the return key on your keyboard or just hit here this part. And then you see this seam line was here extended. And now these pixels here are also used from the upper Orthophoto and not anymore from this lower Orthophoto. Yeah. Just perhaps to show it a second time, just to have the feeling how this works. So this time I want to extend it in the upper direction. So I want here this content not to be used from the upper image, but from the lower image. Let's say there was here a car is here inside from the upper one, and in the lower one this car already moved. So I want now to use from the lower image this seam line. So I say new polygon or extending. So then I start with my first click in the lower one, not here, but here on this side of this green line. Then I click, then I here extend it. Of course, here I would need to take care not to create some issues. Then I return back, and then you see my purple line is cutting the green one. So I make here another measurement. Then I say here extend, and then this seam line here is extending, and then here this this car hopefully then is gone, it's not anymore existing in the lower one, and then you can solve this. There is a little bit more in it, but I don't go it. If you keep the right mouse button pressed for more than 2 seconds, you can here open additionally the real Orthophotos itself. So I can here import or show Orthophoto 3811, then here 3843, and one more time here also 3875. So if you have a second screen, you can move these to another screen. And then when you again start to measure these parts, or let's here zoom in with the drag zoom, I will zoom into this part here, and then we can here follow the zoom and panning. Then we would see this content of existing here. And then when we start again to make a new seam polygon, and now let's return it. So I will expand the upper one. So then I start here into this one here, and then we see on the right side here, we can see here this polygon here drawn, and we can see perhaps if in one of the other Orthophotos I am cutting some object or creating some misplacement, or the Orthophoto does not exist anymore, or the car is still visible, and I would now here draw through the car, and therefore we can here take care not to break something in our production line. And that's it. Then we can here agree, and let's assume this is now fine. Then we save the project, and saving the project is now saving this metadata information of the Seamline into the metadata folder, into these files. And that's it. We are fine now. We have now, of course, you go through all the seam lines and you make the corrections, and then we can now with this information return to OrthoVista. And we need to make now a few changes. One is our Orthophotos, we have written them already radiometrically corrected, so we can go here to the Images tab, and here we will now change the path to the Orthophotos, because at the moment our project file here is pointing to the file that is our original input data. Yeah, we can see it here, 23 minus rectify. So this is our file name that we are currently using, but we already did radiometric corrections to the orthophotos in our process. So what we will now do here is changing here for all our photos. So hitting Control A, and then we can go here and say, change the image path. And then we will here navigate to our OrthoVista folder. And there we have our orthophotos again. If we say select folder, and therefore here we can select them. And I just realized I wrote them as TIFF World and not as GeoTIFF as they have been before. So in my case, I even have to remove them. And then here, loading here these ones again. These are ones here. And they have the same naming, so we can just run it with the TIFF World files now. Tile definition is still the same. Everything stays the same way. Nothing changes. They have the same dimensions, same pixel size. So just should have gone with the GeoTIFF. Yeah, but just that you are aware. Second thing we need to change is in the process, we need now to switch off the global tilting, because our orthophotos have now already applied a global tilting. I don't save now again the orthophotos, but now we will save the Mosaic. And we will not run the feature detection, but we already have used the feature detection. We will now apply our Seamline editings, and therefore we will use here the Seam applicator. And these are really the main parts you need to change. In case you want to write your Mosaic not into the same folder as your orthophotos, please be aware, when you change the output directory, we typically automatically always change the meta directory according to the output directory. So if you want to write your Mosaic somewhere else, make just here a copy of this metadata directory. I hit Control C. Then I change now here my output directory. I will now here create a folder calling Mosaic. But I will here return my copied string. So it's now here not showing into this one, but into the old one. And that's it. Everything is fine. And then we can here close and process. And now what happens here is it will directly now start applying our seam lines into this process, the corrected ones, and write out our mosaics with the naming we defined. And when this is finished, we will just take a short last look, and then I hope you enjoyed this very long video tutorial about UASMaster in combination with OrthoVista. Well, I could have just sticked it. It was already then a few seconds later. Okay, so to do this, we will here just open a second OrthoVista. So I just went to the bin folder of our software, and there's an executable OrthoVista. You can just here right click and send here, of course, to the desktop shortcut. I will here just double click it, and then OrthoVista will open up in the demo mode, because I only have one license, but doesn't matter, because in demo mode I can still take a look at the result. And then it's a folder selection, so you don't see any images, but I will here select this folder. And then we can now see here our mosaics that we created. I can here switch this off. And then we can here also, if we want, then take a look at the seam lines that we have created. You could overlay them and import them here. And there should now here, these fixes now have been used as we did it. And this is now, let me just show the output folder, our final slide or final view. So here we have our mosaics now, and they are tiled, so they have now smaller sizes, so you can easily now distribute them here and work with them further on. They are north orientated with our tile definition that we used. I hope you enjoyed this very long video, and it helps you to get an idea how to enhance your production for large projects in combination of UASMaster and OrthoVista. Okay, thank you. I wish you all the best.